In this course, we will use an important class of the function, which is a trigonometric functions. Before starting trigonometric function, I will give a right triangular trigonometry in this section. In a plane, an angle is formed by rotating a ray M, which is this area M is called the initial side of the angle. Around it is end point. End point is that point. Let's show that. Around it end point until the ray coincides with a ray N. That point, this is array called the terminal side of the angle. Okay, so this is the array N. This is initial side, that is terminal side. The common endpoint P of M and N, this is the common endpoint P, is called the vertex. So this is the vertex. So where is the angle? Angle is this part is the angle theta. There is no restriction on the amount or direction of rotation. That means this is array M, this is array N. So you can describe your region like this one. There is no restriction of rotation. We can turn the clock counterclockwise direction and the amount, so one times. If you want, you can turn the second times. This is the angle. Okay, let's say alpha. Here the direction is counterclockwise direction. So counterclockwise rotation produces a positive angle. This is positive angle. And also you can rotate in the other direction and by starting initial ray. So we go in that direction. Of course you can rotate several times if it is possible. So this angle beta is negative. Negative angle. So clockwise rotation produces negative angle. Two different angles may have the same initial at the terminal side. For example, M is initial array, N is terminal array. Let's use this color. So from M to N, this is positive, so clockwise direction, positive angle. So let's note by the, does not matter, let's say beta or alpha, does not matter. Okay, let's say beta according to your textbook. And the other one is starting from again M, clockwise direction we got. Okay, so this is alpha. So these two different angles are called to be coterminal. So here alpha and beta are coterminal. In the math books, there are two widely used measures of angle, namely degree measure and radian measure. When when a central angle of a circle is subtended by an arc that is 1 over 360 times the circumference of the circle, the angle is said to have a degree measure 1, and it is noted by the 1 up note. So this is the angle, this is center. So this part is 1 over 360 times circumference. So that angle, maybe we can use the red color. This angle is called 1 degree, and it is denoted by this way. So totally this is 360 degree. A central angle subtended by an arc that is 1 over 4 of the circumference has degree measure of 19 degrees. Easily you can observe. This is the 1 over 4 times of the circumference. So this angle is 19 degree. Okay, this is 19 degree. 1 over of the circumference has the degree measure 118. So this angle is 118 and total degree is 360. The other measure of angle, this is the degree, let's write. The other measure is radian. Radian measure. The other measure of angle is radian measure. A central angle subtended by an arc of length equal to the radius of the circle is said to have radian measure, and which is written as a 1 radian or 1 rad. So let's describe. So this length not this length, length, a central angle subtended by an arc of length equal to the radian r of circle is said to be a radian measure, but for the unit circle or for the any circle. So if the radius is r and this length is r, so this angle is called 1 radian. 1 radian, or we say 1 rad. So if this radius is 1 arc length, see the 1 radian. Okay. In general, a central angle subtended by an arc of length s has radian measure that is determined as follows. So in general, theta radian, this is theta, theta radian. Okay, radian measure of this angle equals arc length. Which arc length? This arc length this is S over radius. Radius is denoted by the R, so this is the radius. So that formula equals S over R. S over R. If you use the unit circle, directly arc length equals to radian angle. What is the radian angle of a 130 degree angle? A central angle of 130 is subtended by an arc that is 1 over 2 the circumference of the circle. So theta radian equals S over R implies PR over R. Why? Because it is the half of them. So half of this circumference is pi, because circumference is 2PR. So this is PR, sorry. That means this is pi. So 118 degree equals pi radian. We obtain this result from there. So the following properties can be used to convert the degree measure and the radian measure, and vice versa. So the relation between degree and the radian can be given as the following form. Theta degree over 118 degree equals theta radian over p radian.